Hello and welcome to this episode of Ask the Expert. My name is Matthias and I'm the responsible industry manager for aerospace at TRUMPF Additive Manufacturing. Today I want to talk to you about the TRUMPF 5000 and its unique feature of using preheating temperatures of up to 500 degrees Celsius or 930 degrees Fahrenheit for aerospace applications. But first things first, what are the important details to make this preheating temperature to work in an industrial environment? Well, our round substrate plate certainly helps to achieve a homogeneous heat distribution compared to square substrate plates. But there's more to it. We used an improved cooling concept for axis, build chamber, and optical components to maintain positioning accuracies during the whole build job. Furthermore, we enabled the machine to get below 10 ppm in terms of allowable residual oxygen. That is especially important to avoid oxygen pickup by the processed materials. Talking about materials, in this overview you can see which materials can benefit from higher preheating temperatures. We can already cover a certain span of materials with 200 degree preheating, but trade-offs are all too often necessary. For example, extensive support structures, which means extended build time and increased material use, material parameters with reduced productivity or large efforts for simulation of the build job are needed. To demonstrate the benefits of 500 degree preheating temperature, we choose one material off the chart that is especially widespread in the aerospace industry, titanium 6-4. What we know from this material is that the residual stress can become so large that the support structures break off and the part starts to suffer from warping and deviations. This typically leads to an abort of the build job. Official research results with test cubes showed already how higher preheating temperatures can reduce the residual stress of titanium and with it the deviation of the part. With the TRUMPF 5000 we are bringing these lab results into reality. This titanium casing shows the direct comparison of 200 degree and 500 degree of preheating. You can see clearly how one of the part has been affected by residual stress while the other maintained its geometry. We even simulated the residual stress for both parts and you can see clearly the differences. It is so significant that the values for the part preheated with 200 degree exceed the mechanical properties of the material. That is what leads to the damage of the support structures or cracking of the part itself. This sample shows clearly how you can improve your 3D printing results for aerospace applications by using 500 degree preheating. Have you experienced similar issues with your parts? Then get in contact with us and find out more about this feature. Thanks for watching this episode of Ask the Expert.